Hello everyone, this is Peter. I am an assistant professor in computing science from the University of Glasgow. Today, I'd like to share with you something about signal and wave in computing science, how my message is transmitted on the wireless network. So, what is Wi-Fi? We use wireless network daily. Maybe, right now, you watch this science on the sofa with your mobile devices in the wireless network. What exactly is Wi-Fi? Wi-Fi, or simply Wi-Fi without dash, is a family of wireless network protocols based on the IEEE 802.11 standard. IEEE helps to define standards so that the industry and academia can discuss together how to make the technology better. Wi-Fi is designed to transmit message in wireless format. We used to see it in home or office environment. Wi-Fi is one of the widely used wireless transmission methods today. Wi-Fi is commonly seen in two frequencies. We know that the signal is in a waveform, frequency, and wavelength. Wi-Fi can be found in 2.4 GHz, which is an ultra-high frequency, UHF, or in a 5 GHz format that is called super high frequency, SHF. Radio bands are subdivided into multiple channels, and these channels are the media to send and receive the data you communicate in the internet. So, you may wonder, IEEE helps to define the technology standard. Are the Wi-Fi all over the world the same? The answer is yes and no. For example, there are 14 channels designed for the 2.4 GHz range. The exact number of the usable channels, indeed, fewer than what it originally designed. It is because radio frequency emissions are regulated by nations. For example, allowed channels, allowed users, maximum power level, etc. So, please refer to the guidelines and regulations with your local authorities. Dual band or not dual band. We just talked about there are 2.4 GHz and 5 GHz in the Wi-Fi network. Dual band router is quite popular today, in which it broadcasts two separate channels at the same time. Why we need to do that? Well, one of the important reasons is because there are still lots of the older devices running in 2.4 GHz only. While 2.4 GHz cover a longer distance in an area, 2.4 GHz is relatively slow compared to 5 GHz nowadays. 5 GHz covers shorter range, but in a much faster speed. So it is always good to understand your exact needs. For example, more web browsing, a text-based work, or you are using the internet for game and multimedia, while the later one usually require bigger bandwidth. Or even, you can consider about tri-band. Now, in terms of the network message, there are two common communication protocols for us to transmit a message in the network. That is TCP and UDP. TCP is a short form for Transmission Control Protocol, while UDP stands for User Datagram Protocol. TCP is designed for reliable, ordered, and error-checked message delivery, so that the message in the network will do a three-way handshake, 1 time, 2 time, and 3 time, to acknowledge the message sent in a proper order without data loss. The common application for TCP is sending error free contents. Characteristic of UDP is low latency, and loss tolerant. UDP do not do three-way handshake, so that it cannot promise all the message was sent properly and in the same order. Sometimes we see a frame drop or blur video is due to these reasons, so that common applications on using UDP is mainly found on multimedia transmissions. In a computing science term, we define a structure so that a programmer and engineer exactly know how to understand the message they are sending and receive. In this message, it shows a sample TCP segment header, which is required for all the TCP transmissions. For example, sequence number and acknowledgement number will work in pair, so that the sender and receiver can rely on this number to understand if the message is sent in order and if the message is properly received on the other side. There are lots of the interesting areas we can do research in signal and networking. For example, we need a good algorithm to transmit the message over the internet. How about the compression rate? Can we do better compression rate so that it can save time and bandwidth? And how about decompression? It is a good research topic. Also, we talk about 5G or even 6G. Is there anything we can do more in the cybersecurity so that our data can be protected in the wireless network? Can people steal our information in the air, which we cannot see, but we know that our data is in the air? And how about the difference between Wi-Fi network and cellular network? How about Internet of Things? Can we make some good application by using all this latest tech? It is an area waiting for you to explore. Thank you very much for watching this Science on This Over.